So, hi everyone, today I am going to show you how to interface the MQ2 sensor with the ESP32 and send gas leakage detection alerts to an Android app. So we will start with that Arduino sketch. First, include the necessary header files. Wi-Fi.h. It is to connect ESP32 to Wi-Fi as a client. Wi-Fi secure.h for secure Wi-Fi communication, which will be used by the pub/sub client. Arduino JSON.h for sending and handling JSON data. Secrets.h to safely store Wi-Fi credentials and AWS certificates and endpoints. Now let's talk about the connections. The MQ2 sensor's analog output is connected to the ADC input pin 34 of ESP32. MQ2 ground goes to the ESP32 ground, and MQ2 VCC goes to the 5V pin of the ESP32. Pin 13 of the ESP32 is connected to the relay module, though we are not using it in this example. For more details, you can always follow our blog at vihaniotgateway.in. So inside the guide get MQ2 reading function, we take an average of 50 samples. This helps suppress noise and gives more stable readings. We also create global objects for Wi-Fi secure client and the pub/sub client. Using these, we set up communication with AWS IoT core. Although we can configure a threshold value for gas detection, in this demo we are simply publishing a sensor reading every 5 seconds. The Android app handles alert generation. The handle threshold message functions is called when the threshold value is received from the application side. But again, we are not using this feature right now. The publish message function sends the data to AWS IoT core on a specific topic. The handle MQ2 message function is triggered when a new message arrives. It passes the message and takes action, such as turning a light on or off or setting a new threshold value. The connect AWS function establishes a secure connection with AWS IoT core. Here we load the certificates, keys, subscribe to the topic, and set up a callback function for incoming messages. We have also set the buffer size to 4096 bytes though it is not strictly necessary in this demo. When the device starts, we allow MQ2 sensor warm up for 2 minutes. For a brand new sensor, it is recommended to run it continuously for at least 48 hours before first time use. After warm up, the ESP32 connects to the AWS. So in the loop, the ESP32 continuously reads 50 samples from the MQ2 sensor and averages them. Optionally maps values from 0 to 1024 since the ESP32 ADC range is 0 to 4095. Publishes the readings to AWS every 5 seconds. Checks if the AWS connection is active. If not, it reconnects. Finally runs the MQTT client loop for message handling. That's it. With this setup, you can send gas sensor readings to AWS IoT core and monitor alerts on your Android app. So now click on upload. So after that, it will start uploading. Okay, now the upload part is complete. Then you have to open the serial terminal. So here you can see that that sensor is warming up and it will wait for 2 minutes. And then it will start publishing the readings to AWS IoT core. Okay, warm up time is complete now and the sensor is ready. Now it has started publishing data to AWS IoT core. You can see that current reading is 10 because there is no gas around. Now I will turn on the gas using a lighter and then we will see the change in the readings. So I'm just recording on mobile as well. So here you can see currently nothing is there nearby the sensor and it is publishing the readings every 5 seconds. Now I'm bringing in the lighter close to this. You can see that reading has increased to 6110. The reading is dropping now. Now I'm again turning on the lighter. Then again reading is increasing. Yeah, it reached to the 664. Yeah, that's it. So in the next section, we will show you that Android application to receive this data.